Four compounds, all colourless liquids, are butan-2-ol, butanal, butanone, and 2-methylpropan-2-ol. Two of these compounds can be identified using different test tube reactions. It's the top two that can be identified with test tube reactions. Butanal is an aldehyde, so that can be tested with warm Tollens reagent. Put the word warm in as well, because at A2 you're going to need the word warm. Warm Tollens reagent, which will give a silver mirror, or if that wasn't available, then you could use Fehling solution, which would give a brick red precipitate. Either of those two tests are fine. Butan-2-ol, so the OH is at carbon number 2 of 4 in a line, butan, so it's at carbon number 2. So either side of the carbon with the OH, you've got two carbons, a carbon to the left and a carbon to the right. It's a secondary alcohol. Now, a secondary alcohol will react with something like acidified potassium dichromate. Use the word acidified, it's got acid in there. Again, an important part of the test. Acidified potassium dichromate will go orange to green, and you need the orange to green, not just changes from orange or goes green, orange to green. So acidified potassium dichromate will go orange to green. Incidentally, it'll form a ketone. If it had been a primary alcohol like butan-1-ol, it would have made an aldehyde, and then if you reflux it, carry on heating it, it would turn into a carboxylic acid. But either way, those are the two tests, and then you need a test for butanone. Butanone, well, there's no test, so you need a spectroscopic technique. In other words, you're going to use infrared spectroscopy and find the wavelengths, the wave number of the infrared light that's actually absorbed by the carbon to oxygen double bond as it vibrates or stretches. And again, for the 2-methylpropan-2-ol, you've got an OH group, and you've got to identify the wave numbers of those two absorption peaks. And you can find that from the data book.